Alright, on the back of the notes we have a different technique for solving systems algebraically. It's called solving by elimination. Another way it's called is linear combination. But elimination kind of tells you what's going on. We're trying to eliminate one of the variables so that we can solve a simpler equation. So again, get about 3 steps here, but this time we're going to show 2 different examples side by side because one's a little bit easier than the other. First one, multiply one or both of the equations. So that's the difference between our 2 examples. Multiply one or both of the equations in order to make the x coefficients or y coefficients opposites of each other. So either to make x coefficients or y coefficients opposites of each other. Alright, so that's the key right there. They have to be opposites of each other. So, if we look at the first example, we either need these two to be opposites, so that means one positive, one negative, but the same number. Alright, so we could have a 3x and a negative 3x. Here, these could be opposites. This one will be a little bit tougher. Those don't go together as well. So just like the examples from earlier, we want to look for that variable that's all by itself, if there is one. So in this case, this 1x, that's the easiest one to change. Just like it was the easiest one to solve for, here it's the easiest one to change to make the opposite of the other. So this is a 3x. We want this to be the opposite of that. We want it to be a negative 3x. To do that, we multiply by negative 3. So we're going to multiply both sides of this equation by negative 3. So that gives us negative 3x plus 6y, don't forget to distribute, equals negative 18. And I'm going to go ahead and rewrite this one right underneath it. Right, the reason why we multiplied and got those to be opposites is this next step that we're going to do asks us to add the 2 equations and solve for the remaining variable. So if we add these 2 equations, we've got them lined up so the x's and y's and then the constant terms are all lined up. If we add these, negative 3x plus 3x gives us 0x. That cancels out. Now we don't have x at all anymore for this problem, for right now. Add these, we get 11y. Add these 2, we get negative 11. So we've gone from 2 equations with 2 different variables to 1 equation with 1 variable that's really easy to solve. All we have to do is divide both sides by 11. So we get y equals negative 1. So we solve for that remaining variable. But just like before, that's not it. We're not done when we get y. We have to figure out what x is. To find out what x is, we have to plug this back into one of these 2 equations. Doesn't matter which one, but we have to plug it in for one of them. So I'm going to use this second equation. I'm going to put negative 1 in place of y. So we have x minus 2 times negative 1 equals 6. So negative 2 times negative 1 is like a positive 2, so x plus 2 equals 6. Subtract 2 from both sides, we get x equals 4. So our answer for this one is 4, negative 1. Right, those 2 lines intersect at the point 4, negative 1. Now, example 2 is slightly more challenging. We don't have an x or a y that's all by itself, just like a 1x or a 1y. So what happens here is we have to multiply both equations by some number to get either the x's or the y's to be opposites. So we've got a few options here. We can make the x's opposites. We can multiply like the top and bottom by something. We have to figure out what do 4 and 5 both go into. Right, the smallest number they both go into is 20. So if we multiply this to make it a 20x, multiply this one to give us a negative 20x, then they would eliminate. Or we can do it with the y's. If you look, the y's are a little bit easier. One's already negative, one's positive. We know that eventually they have to be like that. One positive, one negative, but they have to have the same number there. Here, 3 and 2, smallest number that they both go into is 6. So if we can make this a negative 6 and make this a positive 6, then they're going to eliminate. So that's what I'm going to do for this one. We could do it the other way, but I like this one better. I want to make this a negative 6y. So to do that, all I have to do is multiply by 2. So if I multiply by 2, don't forget to distribute, we get 8x minus 6y equals negative 12. For the second one, we want this to be a positive 6, so it's the opposite of this. So we're going to multiply by 3, and we have to do that on both sides. And again, we need to distribute. We get 15x plus 6y, so now those are opposites. That's going to work the way we want it to. And then 3 times negative 19 gives us negative 57. Second step, we add them. And once we get those to be opposites, we can add the two equations. So we get 23x, 0y equals negative 69. Divide both sides by 23. X equals negative 3. So we're putting negative 3 in for x. 4 times negative 3 minus 3y equals negative 6. Negative 12 minus 3y equals negative 6. Add 12 to both sides. Negative 3y equals 6. Divide both sides by negative 3. Y equals negative 2. So our answer for this one is negative 3, negative 2. Remember, you can always go back, substitute that in to see if it works for both equations.